Thanks a lot. Thanks for the introduction. Yes, we are going to talk about the tip of the iceberg, protecting AI systems against old and new threats. So basically, we have all those fancy new AI systems, but what can we do with traditional protection measures to protect those new kind of systems that we see now popping up everywhere? And they take a larger and larger place in our organizations, in our IT infrastructure. We are first going to look at AI risks. What is the risk landscape regarding AI? What can happen? What can go wrong? Also a bit into the regulation side. What about the AI Act? Then we are going into a more practical example, like a strat model that we practically did with one of our customers. And then we are going to contemplate a bit about the learnings from this. So what role do AI-specific threats play? What role do more traditional threats play in protecting those kind of systems? So let's start at the beginning with the risks. There was a nice quote from Meredith Whittaker, the president of the Signal Foundation, who said, the marketing, the value add is something like this. AI can look up a concert, block it in your calendar, book tickets, message all your friends that it's booked. So you can put your brain in a jar. Sounds very nice, but what would it actually need doing that? And if we think about those examples, it sounds very convenient, and AI can take over all of our tasks. It's super practical. But what does it need doing that? So what kind of access does it actually need if we wanted to fulfill those kind of tasks? And it's a lot of stuff. AI would need, for example, access to a browser, credit card or payment information, calendar access to a messenger to message your friends that you maybe go on a concert together. It would probably need this kind of access to your data unencrypted because it needs to work with it. And it needs probably access to a cloud service because you cannot yet do all this on your local devices. So this creates a kind of mixture between far-reaching access, large data pools, data exchange, and automated agency, which is quite problematic from a security and privacy perspective. But you could argue, where's the problem? AI systems do exactly what we tell them to do. After all, they are used to do that. They listen to us. They like to help us. They are programmed in a way that they support us. So nothing can go wrong, right? Well, there are other experience. There was this one company, Replit AI, coding platform, basically, which ignored a code freeze instruction and deleted the production database of some other company that was using it to provide their services. So basically, there was the command to the AI, do not touch production. It did that anyway, deleted the production database, also claimed it was not recoverable. Luckily, it was. But nonetheless, everything went in a way that was not really expected. And as Jason Lemkin here states, there is no way to enforce a code freeze in vibe coding apps like Replit. There just isn't. In fact, seconds after I posted this from our very first talk of the day, Replit again violated the code freeze. So code freeze does not really work. We could say, well, this is a while ago. Maybe it's better now because we have some kind of guardrail systems that we can try to protect our AIs a bit better. Also, those kind of systems do not really work reliable. I found this quite telling. DeepSeek safety guardrails failed every test researchers threw at its AI chatbot. There were like 50 tests, all failed. Not a very good impression. You could argue, okay, well, this is like on the coding base. Maybe for consumers, it's not as bad. But if you use new browsers, maybe the Atlas browser, then you see again, there are some issues with AI. So here it is about a vulnerability in OpenAI Atlas browser, allowing injection of malicious instructions into ChatGPT. So ChatGPT keeps a context basically with the OpenAI session. And here attackers found a way to inject content in your session that you keep between the browser and the OpenAI API that is used to instrument the browser and basically the LLM instrumenting the browser, this context that is maintained there. And we will also later see that this is a quite interesting vulnerability because what was responsible here in the end was the cross-site request forgery vulnerabilities. Yeah? So it was not like some fancy new issue. It was something that we know for a long time that was exploited here to get this kind of access. And it's also not limited to Atlas browser, but Atlas did apparently not very well protect the users against cross-site request forgery attacks. As this risk landscape continues to evolve, and it's a complex thing, luckily there's an OWASP project dealing with it, and you probably heard of it by now. And this is the OWASP Top 10 for large language models, or Gen AI. There's this Gen AI security project at the OWASP group, which does a very good work in maintaining and describing those different attack vectors that they see relevant for LLM models. If you want to dive a bit deeper, there's also like the machine learning top 10 that might be more suitable to other systems depending on your context. There's also a bit of overlap. Those are both two quite good resources for diving into vulnerabilities if you deal with Gen AI systems or LLMs specifically. The vulnerabilities that you see here, you might have heard about some of them. Prompt injection, for example, I believe everyone knows by now what this is. Basic stuff like sensitive information disclosure, supply chain attacks, data and model poisoning, improper output handling, and so on. We will use that again in the threat model example with a bit more detail. If you look at the risk levels for AI systems from a bit of a higher level, however, this is quite already specific. You can go to other categories of risks that are also involved with AI systems. You have health and safety risks. So could the AI failures lead to physical harm or unsafe conditions? You have operational and financial risks. Errors disrupt production, lead to wrong decisions, and so on. Fundamental rights and ethical risks that come with AI systems. Data and privacy risks, of course, because no one loves data as much as your AI systems. You have cybersecurity and reliability risks. And then you have compliance and legal risks, of course, because also the landscape across AI regulations grows. One of those relevant things for AI regulations, which you also might be aware of, is this EU AI Act. And this is basically enforced by now, and it is an attempt by the European Union to classify AI systems into different categories. You have systems with unacceptable risks, for example, forbidden systems like social scoring systems that we do not like to see, manipulative AI, detecting of emotions outside of therapeutical use, and so on. Then we have high-risk systems that usually affect safety or health or rights of people, like employee management systems, decision-making systems, and so on. We have limited-risk systems that involve the risk of manipulation or deceit, like these AI systems must be transparent and humans must be informed about the interactions with those systems. And then we have minimal risk systems that are basically those systems that we have known more or less for a longer time, like spam filters, traffic routing systems, and so on. This is a classification that the European Union developed. And then there are also some specific requirements for general purpose AI, like providers must provide technical documentation and so on. Now we're going to look at a bit like how to apply these risks in terms of a threat model. And for that, I would hand over to my colleague who shows us a bit around a RAG system, how this can be done.
Hello. Yes, exactly. So thank you, Michael, for the introduction. So we already had like a few examples about different approaches, how we can use large language models. So we had the agent systems. We already had mentioned the normal LLM approaches, but I want to talk today about a different approach, and this is the RAG system, the so-called Retrieval Augmented Generation. Maybe some of you have already heard about it, and I think it's a really interesting approach because what it is, it's like a normal large language model that we are mainly, maybe most of us using daily already, but with like some internal data. And maybe we start with the, from your point of view, right side here, with the architecture. So we have a user that is still using a normal web interface. You can imagine you have your ChatGPT interface and normally interacting with your prompt and asking normal questions. And then you have your API backend and you have your SageMaker. There you hosted your internal large language model, any local large language model that is available. So any open source large language model. But what is now newly added is this vector database, and there is some internal knowledge that you added to this system that you can ask some internal questions. And how you create this vector database is in this AWS example here, for example, is that you just upload some internal documents in your S3 bucket, and with an so-called with this document loader, that is some embedding model that will create some fancy chunks and everything. This will create then a vector database that will send these information then to your large language model. And then you can ask internal questions to your large language model, and this will help you with internal questions really fast. Maybe we also, of course, have a small use case, and to make it a little bit easier, a user wants to identify the right supplier for a product. Just imagine you need a screw, and you have a list of suppliers that can deliver the screw, and you can, of course, just go through the list of suppliers and have a look who has like the best, the cheapest price, maybe the fastest delivery time, maybe also the best quality on your experience. But why doing this? You can also just upload it in your S3 bucket and then automatically generate this vector database, and then just ask your ChatGPT or your prompt, what is the cheapest price if I want 100 screws per day, or if I need 100 screws per day, or what was the best quality in experience from the last month, just from these questions. And the backend contacts your database from the vector database and will then just suggest 3 matching suppliers. So you can, of course, also get more. This is depending on your commands that you give with your LLM. But you can make 3 suggestions or even more. And then, depending on the suggestions the LLM makes for you, you can decide and you can make decisions, and then afterwards can contact your supplier. And what you need in the end is just you need some documents. This can be PDFs, XML, CSV, everything you have. You can also have your normal SQL database that you can include in the system. And yeah, just in the end, need to upload it in your system, and in the end have like a large language model with internal data. Just as a small example. But of course, with internal data and large language model, there come security risks. And Michael already mentioned there's like the always top 10 large language model. And I don't want to talk now in this small time frame about all the top 10 now, but I highlighted here 3 important topics. I want to start, of course, with sensitive information disclosure. This is also a topic here with the large language model, because when you upload documents in your S3 bucket in our example, you have a lot of users who have access to all the documents that you uploaded, and you have then in the prompt can just ask like in these about all these documents, and then in these documents there might be sensitive information. So you need to have a look what these documents might contain, and you also need to check who has access to this large language model in the end. That's really important. And I also want to talk about number 8 and 9 a little bit combined. Number 8 is specifically a risk that talks about the RAG system, the vector and embedding weakness. Embedding weakness is for RAG system is when like might be some problems when you create this vector database. So if, for example, there is some problems in the vector database and you will not get the right supplier like recommendation, then if there's a problem that you get not the right supplier recommendation, there's some misinformation leading. So if I ask what might be the best 3 suppliers, and all the time I don't get one supplier because there's some problems in my vector system, this will lead to some problems for me and also for the supplier. So that's also a risk that I cannot really see if there might have been a problem when there has been calculating and processing the data inside my embedding model. So that's also a risk and a security risk at all, because it might lead in misinformation that we need to check all the time. The other risks are also really important. These often talk a lot about architectural risks, and architectural risks are often really important about threat modeling. But therefore, I will also again hand over to Michael.
Mm-hmm. Thank you. Yeah. So basically, what we did here was this. Where's the thing gone? Yeah. What we did was a system. We wanted to do a threat model, but we also wanted to have a complete analysis here in terms of the specific AI risks. So that's why also with the threat modeling, we focus on the AI risks. The threat modeling steps, usually this is this 4-step framework. So you clarify what are we working on, what can go wrong, what are we doing about it, and have we done a good job. So this Adam Shostak's 4-step framework we applied here, focusing on the LLM risks. What we also did is that we try to embedding this threat modeling in a bit more overarching process, because we have seen this European AI Act. So before you threat model a system, in a way, you need to clarify what kind of other requirements do you have on that system. And usually in larger organizations, you have areas like data protection and so on that get also involved. In this case, it was a bit smaller setup, so we did just a focused process that includes the EU AI Act requirements. And therefore, we did this first 3 steps here where we involved basically a kind of compliance check for the EU AI Act to determine which kind of requirements from the AI Act we would need to take then into the threat modeling activities to also consider those kind of risks. What we did here was first, of course, going a bit into analysis, high-level understanding of the system, then classifying the system under the EU AI Act in a risk category, identifying then the compliance requirement that derive from this EU AI Act, and then basically go into the threat model. So basically, we merged those kind of requirements from the AI Act into the threat modeling activity. And if you're still new to that, you can use this AI Act compliance checker on their website. It's quite convenient. You can click through a few questions and then you get a result. So basically, in this case, as this was dealing more with suppliers and product part numbers and so on, this was not like a high-risk system or anything. This was a default case where you had just those Alphabetisierungspflichten, like this informational requirements to inform your users that they are interacting with an AI model, because you always have those risks of hallucination of the AI, even with RAG systems, where this risk is reduced because you provided a good information base usually, but you still have the risk that the AI randomly or probabilistically generates content that does not match with your actual data or requirements. So in this case, we just had this kind of information requirements for users. If you look for high-risk systems, this picture would look different. So here we were in this part where we had the transparency and user training requirements. If you're going for a high-risk system, you have risk management, integration, data governance, technical documentation requirements, transparency, provisioning, human oversight requirements, accuracy, ensuring accuracy requirements, opt-out, human intervention requirements, and so on. So there's a lot of more detail that you need to take into account once you move in this kind of high-risk area. In practice, also, what we did is that we basically used those kind of requirements from the different input systems, from the different standards, and compiled our own threat list out of this. So we try to not have too many threats, because you can go into a lot of detail with those kind of threats, but have something practical that we can use as a checklist for our threat modeling activities. And also this AI is really great at matching text. That's what it's designed to do. So we used AI to do that. We threw everything in. We compiled it, formulated a few prompts, and so on. Then, of course, rechecked it a bit to make sure that it did not hallucinate, that it did not mix too much. So you cannot skip this step. But like in this preparation work, AI is really great. what came out was, you can probably not read this, but we have a list where we basically said, okay, this is a category of threat we want to look at. This is a threat like prompt injection, adversarial attacks, training data poisoning, backdoor injection, model inversion, membership interference attacks, and so on. Then gave it like a description and a countermeasure suggestions here. And also mapped it to this OWASP LM and then had it cite the sources just to make sure that we really did not include any hallucinations. We used this list, went into a typical threat model, make some documentation here with prompt injection. How likely is that? Yes, a user modifies the AI prompt. In this system, it was very good because the prompt, and whenever you can do that, avoid free text prompts to LLMs. Better construct your prompts out of strings, or like select boxes or whatever you can use to constrain users in the information and the commands they put in, because then you can avoid this kind of prompt injection way more easily and don't have to deal with it. Otherwise, this is hardly avoidable. Sensitive data exposure and so on, AI supply chain compromise. So these are all stuff that is a bit process related. Denial of service, unbound consumption. This is something that you might have to configure in your cloud provider and so on. And if you look a bit at the countermeasures that we listed here, it was like, well, do input validation. We have this form constructed. There is no free text. Perfect. So we can do some kind of input validation. We just ask product part numbers. Maybe they have a specific format that we can check. And so on. Ensure no sensitive data in reg files. That's the easiest way. You don't want to spill sensitive data, don't include it in the system. Limit input, limit the cloud resources, ensure that you use your model from trusted sources and so on. And it emerged a bit the feeling that nothing of this is really new. We avoided prompt injection, and from the rest there is still the risk like output integrity attacks. There is still the risk of hallucinations and so on. But a lot of the stuff that we saw in the threat model was basically like, okay, it's the old stuff applied to a new system. So this was a bit the feeling that we got there. And this also brings us to the third part, the learning part, where we started matching a bit. We thought, okay, let's take the OWASP top 10 LLM and let's take the OWASP top 10 for applications and see what kind of overlap is there. And this is not a complete mapping here, but it looked like there was quite a bit overlap. So you have prompt injection, but you also have SQL injection. They work a bit differently. It's not exactly the same thing, so the root cause is also a bit similar. You have things like supply chain security, or you have information disclosure and security misconfigurations. All those things that you do already with your web applications, with your services, with your interfaces, they also apply to LLM systems. There are some new tweaks and so on, but there's really a lot of overlap. And this is also true, I think, for the new OWASP top 10 that just have been published, I don't know, a week ago or so. I think at least there was this release candidate out there. They did not change too much, so it's still the same thing that we see. Also here we looked into really mapping this a bit and looked mapping it by the countermeasures basically that were suggested by the OWASP models. So we see that this is the LLM risk, and then you have the web OWASP counterpart, prompt injection to injection, for example. Then what kind of countermeasures were suggested, and then there was a rating on the overlap that we also asked the LLM to do. So it's basically a word matching in a way, but I think that works quite well in this case because you can really see what kind of countermeasures are recommended for both these kind of controls from both standards. Then you see that for sensitive information disclosure, there's a high overlap. For example, supply chain vulnerability. It's I think quite self-explanatory that this is really the same. Things like input filtering, output filtering, data hygiene, trusted sources, encryption, rate limiting are very familiar countermeasures. And coming back a bit to the title of this talk, so we have this tip of the iceberg metaphor where we said, okay, we have a bunch of AI-specific risks, injection, adversarial attacks. These are quite, so prompt injection, let's phrase it, and adversarial attacks. Those are AI-specific attacks, over-reliance, excessive agency, because once you go into this kind of MCP automation direction, you have to think about this risk, which you can also constrain with access control again. So there's again some overlap. But the traditional risks are also quite prominent: supply chain information disclosure, denial of service, access control risks, data quality risks, output handling risks. So there's a lot of common ground, I would say, between the covering the new systems with old measures. And yeah, if we look at this here, what still helps, good old protection mechanisms and proper security controls still help to reduce AI-related risks. So what should you do? Of course, the usual stuff: input validation, access control, rate limiting, supply chain security, human in the loop for critical process, for everything where it's really, really, really important. Sandboxing, monitoring and logging, encryption and IP protection measures, risk awareness trainings and governance. And we also found that usually it's quite safe to assume that what you put in a large language model, or what you put in, or what you give a large language model access to, you can not consider safe. Just if you keep that in mind, I think you're making a good approach to securing your LLMs. Whatever data is accessible by an LLM, or an LLM gets trained with or has access to in terms of RAG, it's very hard to secure this with the measures we have at the moment available. So, and maybe let's come to the last slide here. So what did we take away from this? Traditional threat modeling works very, very well also with AI systems. So you just need to enhance your threat landscape a bit, but you can still use the same processes. The use cases of AI systems needs to be considered. So it really depends on where do you place your AI systems in this kind of process chain of your organization to determine what kind of risk level it receives from the EU AI Act and what kind of requirements then you also have to fulfill. This kind of access to data in agencies. So this is really the critical thing, and this increases the protection requirements for AI systems in comparison to traditional systems, and with this bit specific dimension. And still you have those very traditional defense mechanisms, this kind of security hygiene that, if applied, provides you already a very, very good ground to protect your AI systems. So do not only focus on prompt injections, but really focus on the complete architecture, and then you will be well covered. Yeah, and I guess that's it. Thanks a lot for your attention.
Okay, the audience, do we have questions? Yes, there one.
Hi, thank you for the presentation, very interesting. I was curious to know, what are some tools that you would recommend to, let's say, countermeasure all the new threats for AI? Do you have any recommendations?
No.
Okay.
No, I do not have any recommendations. So we looked a bit into guardrail systems, but in my opinion, those they raise the barrier for attackers. But it's not like you get 100% security here. So
Exactly.
We did not find like a golden solution to really protect AI systems. So this is a bit by nature of the systems. Once you have those kind of data in there, and you have this kind of prompt digestion by the systems. We looked at this in the workshop on Saturday with a lot of detail, how these probabilities get processed, but there's no really way to secure this data inside there. So I think there are some testing frameworks now. I heard of a I don't want to make any advertising. Someone told me of a framework called Spikey or something, which can be used for adversarial testing. Might be interesting to take a look at. There's this guardrails AI page, I think, which also has some open source guardrails that you might experiment with. But in my opinion, there is not this golden tool. So I go for the direction of avoid giving access to sensitive data to those things. Or then if you do it, then you have to do access control around it.
Thank you.
Any more questions there on the left side? Please throw it over there. On the right side from the entrance.
Microsoft is currently rolling out its Copilot within the company settings, for its company customers, because it's helpful, but it's also a business model. How do you look at that security in the Microsoft framework of OneDrive, OneNote, Outlook, Power Automate?
It's
happening.
a difficult
It's
question. I know
happening.
it's happening, and I mean, we have seen the Echo-Leak vulnerability and so on in the past, so I think there have been enough examples where it did not really work out. So in my opinion, this still is probably a learning space also for Microsoft to how to properly secure this. I would be careful, but I know on the other hand that a lot of companies use these tools and you are required to use these tools, so it's also hard to avoid. So I would try to be careful as possible with what it gets access to. So I think it's very hard to keep this data really confidential.
Thank you. One more question there.
Yeah,
Okay.
sorry. To link back to these questions about Copilot integration with your ecosystem, you just mentioned just keep away from LLM all the data you consider sensitive. Well, with Copilot integrated in your Microsoft tenant, then the whole data is already integrated with Copilot.
Yes.
So would that apply also in this case, or what would be your suggestion there?
I cannot tell you how to secure this. I mean, this is always the issue if you work with Microsoft Office tools or Office Cloud. Yeah? So Microsoft has access to it anyway. So the question is how is it protected from different users? And I cannot really answer that because I'm not familiar with the Microsoft architecture here. It's how it is really separated on an instance level or on a physical level in the end. So if there are different instances running, including different customers' data and so on, so I cannot really answer that. So I guess since you already give a lot of data to Microsoft, you're in a way fine with also giving that kind of data with Microsoft, but I would not be happy about it. So let's say like this.
Yeah, I mean, you usually have a DPA with Microsoft itself.
Yes,
when you sign
right.
a contract. But
Right.
like the question is, do you have a risk that this gets leaked, as you mentioned, to
Yes.
other
I w-
Microsoft tenants, not the Microsoft itself?
Yeah,
So,
okay, I cannot
the
answer-
enemy is
yeah.
not Microsoft, but
Yeah.
Is it more risk for Microsoft or is it more risk for us?
Oh my God, yeah, this is... I'm not sure. I cannot really give an answer to that. I'm sorry. I mean, it depends on the contracts you have with Microsoft, but I think Microsoft also has a good legal team, so it might be difficult to really hold Microsoft accountable for whatever happens then. But I don't know. I cannot answer that. It depends on how Microsoft sets this up in the background, and I don't think we have insight into this. So no, not really.
Thanks.
Yeah.
Okay, then please a short applause. Thank you very much.